everybody, I hope you guys are having a wonderful day today. In this video, we're going to learn the addition algorithms for other bases. So in our previous lesson, we learned all of the different addition algorithms for base 10. So things like the lattice method, the standard algorithm, the intermediate algorithm. We talked about how to use base 10 blocks to model multi-digit addition and also how to use a chip abacus. And now what we're going to do is we're going to learn the same algorithms, but we're going to apply them to other bases. So things like base 6 or base 5 or base 12. And the purpose of doing this is to help you guys learn on a deeper level how to explain these algorithms to your students. Because when you learned the base 10 algorithms that I taught you in the last lesson, it was relatively easy because you have memorized all of your addition facts in base 10. But when you teach this to your students, they don't have those addition facts memorized. They're just starting to learn it. And so in this lesson, it's kind of going to put you in your student's shoes because you don't know base 6 very well or base 5. And so by doing all of these algorithms in another base, you're going to understand what your students will feel like when they're learning base 10 for the first time. So let's start off with a simple addition problem in base 6 and talk about how we can think about these even though we don't have our base 6 addition facts memorized. So if I have the number 5 plus 4 in base 6, one way I can model this is with number line addition. So since I'm starting at the number 5, I can go to the number 5 on my number line, which is right here. And then if I'm adding 4, then that basically means that I'm going to go forward 4 units. So here's 1, 2, 3, 4 units. And so that tells me that 5 plus 4 in base 6 equals 1, 3 base 6. Because remember, in base 6, once you get up to the number 6, you change place values. So in base 6, this notation that looks like a 10, it actually represents the amount of 6 things in base 6 because it's saying that you have a 1 in the 6's place value and a 0 in the 1's place value. So in base 6, 5 plus 4 would equal 1, 3, or what it looks like is 13, but it still represents the number 9 in base 6. Now, one way that you could also think about this is you could use your thinking strategies and you could think about this as 5 plus 1 plus 3 in base 6, because 5 plus 1 in base 6 is going to equal what we would say looks like a 10. So you're going to have a 1 in the second place value. And then when you add 3 to that, that would give you a 3 in the 1's place. So just like we used base 10 blocks when we were adding numbers with the base 10 numbers, we're going to use some base 6 blocks to represent our addition problems in base 6. So as a reminder, when you're working in base 6, when you get up to the number 6, then you change place values. So if I have these unit blocks and I have 6 of them, those can be combined together into a 6 rod, which in base 6 would be written as the number 10. So it would look like it was the number 10, but it actually represents the number 6 because the rod has 6 things in it. Then if you put 6 rods together, that makes a plate that has 36 things in it. And then if I put 6 of these 36 blocks together, that would make a big block, which would have 216 blocks in it. And that number in base 6 would be written as 1000. So it would look like our base 10 number 1000. But it would actually represent the number 216 because there's 216 blocks in this block. So if I wanted to add the number 341 base 6 plus 112 base 6, I could represent that using my blocks. So I'm going to take my 216 block out and I'm going to make 3 of my hundreds blocks. They're not hundreds, they're 36s, but they're kind of like the base 6 equivalent to that. And then I'll have 4 of my rods. So here's 1, 2, 3, 4. And then I'll have 1 unit. And then I'm going to be combining those with 1 in my 6 squared place value, 1 in my 6 to the first place value, and 2 units. So when I add these together, it's pretty easy to do because if I add 1 plus 2 in my units column, well, that means that I'm just going to have a 3 in that units column. Then if I add 4 rods plus 1 rod, that's going to give me 5 rods in my sixes column. And then if I add 3 plates plus 1 plate, that's going to give me 4 plates in the 6 squared or 36 place value column. And so my answer to 341 plus 112 in base 6 would be 453 base 6. So this is a relatively easy problem because we didn't have to carry anything, but we could also do a more complicated problem. So if I had 2154 base 6, I would have 2 of my blocks that have 216 in them. So I'd have 2 of those. Then I would have 1 of my 36 plate. Then I would have 5 6 rods. So here's 1, 2, 3, 4, 5. And then I would have 4 of my units. So here's 1, 2, 3, 4. Then for my second number, 534 base 6, I would have 5 of my plates. So here's 1, 2, 3, 4, 5. Then I would have 3 of my rods. So here's 1, 2, 3. And then I would have 4 unit blocks. So here's 1, 2, 3, 4. Okay, so now when I add these together, if I take 4 units and I add them together with 4 units, well, those can be combined into a base 6 block because there's enough when I add 4 plus 4 to make a 6 rod. And when I combine that 6 rod with these other 5 6 rods and these 3 6 rods, well, I can make those and regroup them into a plate. And then when I add all my plates together, I can regroup those as well. Whoops, I think I'm going to need 6 of them. So when I regroup those, that makes a 2/16 block. And so when I add these numbers together, I end up with 3 of my 6 cubed or 2/16 blocks. I have 1 plate of 6 squared or 36. And then I have 3 6 rods and 2 of my unit blocks. So my answer, when I add 2154 base 6 to 534 base 6, it would be 3132 base 6. And that would be my answer for that problem. So on your homework, you're welcome to use the applet to help you visualize what the different bases would look like and what the numbers would look like. But then after you feel like you understand that, I want you guys to try doing some of the problems on the homework without the blocks. Because ultimately, when you're teaching these concepts to your students, you're not going to want them to constantly have to use blocks in order to do addition, but you do want to use the blocks to build the foundation. So in this lesson, you're going to go through the same process that you'll lead your students through, where you will learn them with the blocks, and then you want to extrapolate it and be able to do the problems without the blocks by imagining what the blocks would look like. So for example, let's go through the intermediate algorithm. So remember, with the intermediate algorithm, you focus on each place value one at a time. So to start, we would say, okay, well, if I have 4 units plus 2 units, well, 4 units plus 2 units is going to be 6 units. And in base 6, we write that number as 1, 0, because you have a 1 in the sixes column and a 0 in the units column. And so with the intermediate algorithm, we're just going to write it like that. Then for the next place value, if we have 5 rods plus 3 rods, I can use my thinking strategies and I can say, okay, well, if I do 5 rods plus 1 rod, that will get me up to the next place value because I'll have enough rods to combine together into a plate. So if I do 5 plus 1, I'll have a 1 in my plates column. And then I'll have 2 rods left in this column because the 1 had to come from the 3, but I'll still have 2 more numbers beyond that I need to add. And so 5 plus 3 in the rods column, or the sixes column, would be 1 plate and 2 rods and 0 units. And then in the next place value, I would say, okay, well, if I have 2 plates plus 1 plate, that would give me 3 plates, which in base 6 looks like the number 300. It actually means that it's 3 groups of 36, not 300s, but the way we would write it would look like that. And then if I have 5 of those big blocks that have 216 in them, I would have just 5 of them because I'm not adding it to anything. So I would have 5, 0, 0 there. And then to find the answer, I can add up all of this. So 0 plus 0 plus 0 plus 0 units equals 0 units. 1 rod plus 2 rods gives me 3 rods. 1 plate plus 3 plates gives me 4 plates. And 5 of the big blocks plus nothing just gives me 5 of the big blocks. And so the answer to this problem would be 5430 base 6. So that's how you would use the intermediate algorithm to find the answer. But you could also use the standard algorithm. So if you were to use the standard algorithm, you would say, okay, well, 4 units plus 2 units is 6 units, which means that I'm going to have a 0 in the ones column and a 1 in the sixes column. So instead of writing the 1 down here, I'm going to write it in the sixes column and then add all of the sixes together all at once. So I'll say, okay, well, 1 plus 5, 6 rods is going to be 6 rods. So that's going to go over into the next place value, and I'll have a 6 squared plate. And then I'll also have a 3 in my sixes column. So I'll keep my 3 in my sixes column, and then I'll have 1 in my 6 squared column. And that's because in base 6, 1 plus 5 plus 3 equals the number 13 in base 6. Then I can go on to my next place value, and I can say, okay, if I have 1 36 plate plus 2 36 plates plus 1 36 plate, then I'm going to have 4 of them. And the reason I'm calling it a 36 plate is because in base 10, the number of blocks in the 6 squared plate is 36. But in base 6, it's kind of like their equivalent of 100. But it equals 36 things instead of 100 things. So that would be that. And then for my last place value, my 6 cubed or my 216 place value, I would just have 5 of those blocks. So you can see we get the same answer that we got with the intermediate algorithm. It's just a shorthand way of writing out the process of the intermediate algorithm. So that's how you could use the standard algorithm. And you could also use the lattice method. So if you wanted to use the lattice method to solve a problem like this one, you would say, okay, well, in base 6, 1 plus 5 is going to equal the number 10 because you have a 1 in the sixes column and no units. And then if you do 4 plus 3, we can use our thinking strategies and say, okay, to get from 4 up to 6, which is when the place value switches, I would need to do 4 plus 2. And since I'm doing 4 plus 3, I'm going to have 1 extra unit that doesn't get exchanged for the next place value. So 4 plus 3 equals the number 1 because I'm going to have 1 6, and then I'm also just going to have 1 unit. So that would be what 4 plus 3 would be. And then 2 plus 3 just equals the number 5 in base 6 with a 0 there. And then to complete the lattice method, I'll just add up along the diagonals. So I'm going to have 0 units. Then if I add this 1 6 rod to the other 6 rod, that gives me 2 6 rods. Then if I add 1 36 plate to 5 36 plates, that's going to give me 6, which in base 6 is written as 1 0. So I'm going to put a 0 here and a 1 up here. And then when I move on to that next place value, 1 plus 0 is just going to give me 1. And so 241 base 6 plus 335 base 6 is going to be 1020 base 6 with the lattice method. And notice that this is very similar to the intermediate method, where with the intermediate method, when we did the 1 plus the 5, we still got 1 0, and we wrote it like this, versus in the lattice method, we wrote it like this. And when we added up the second place value, 4 rods plus 3 rods equaled 1 rods, which again, we got the same thing there. And then 2 plus 3 gave us the 5, which also gave us that there. And then when you add it all up, you do get the same final answer. So that's how you would use the lattice method to add numbers in other bases. And so on your homework, you guys will be using these different methods to add numbers in other bases. And you're welcome to use the block applet to help you think about it if you would like to, but also make sure that you understand how to use the thinking strategies, because on your tests, you won't be able to use the blocks. And so you need to build your understanding to the point where you can do them without the blocks. So if you have any questions, let me know, and I hope you guys have a great day.